Hi friends, hello, good morning. This is Kishore, working as a physics lecturer at Vignan College. So we are learning the lesson mechanical properties of solids. So in the last session, we learned the experimental determination of Young's modulus of a wire. So Young's modulus is given by y is equal to FL by AX or FL by AE. So by using this formula, we can find the Young's modulus of a given wire. So we have seen in the last session the experimental determination of Young's modulus of wire. So in this session, we will discuss some problems relating the Young's modulus of the wire, stress and strain, and in this chapter. So let's start this session. So before going to the problem, so let us see some formula, and we learn some formula. So in this mechanical properties of solids, so we already know the formula for stress. So stress is given by restoring force by area. So stress is nothing but F by A. So we know the force if not given, then F is equal to mg, and if the area is given, not given, then area can be written as pi r square. So this is the formula for stress. And strain is nothing but change in length by original length, or it can be delta L by L. So there is expression for strain. And Young's modulus is denoted by Y, which is given as the ratio of longitudinal stress divided by longitudinal strain. So which is nothing but longitudinal stress is F by A, by longitudinal strain is delta L by L. So Y is equal to FL by A delta L. So this is the formula for Young's modulus. So if the force is not given, then I have to take mg, L by, and area is not given. If the radius is given, then I have to write pi r square. So this is expression for Young's modulus of the wire. Y is equal to mg L by pi r square delta L. And we know there are three types of modulus of velocity. This is about Young's modulus of velocity. And coming to rigidity modulus of velocity, it is nothing but, so it is also equivalent to FL by AX. Here F is the force acting and L is the A is the area of cross section, X is the relative displacement, L is the perpendicular distance. So this is about the rigidity modulus. And coming to the bulk modulus, it is nothing but minus PV by delta V. Here P is the pressure and V is the volume and delta V is the change in volume, and we know P is nothing but force by area. So this is about the bulk modulus. And coming to the compressibility, which is nothing but the reciprocal of bulk modulus, is equal to minus delta V by PV. So this is about the compressibility. So now we will see some problems depending on this formula. So see the first problem. A copper wire of 1 mm diameter is stretched by applying a force of 10 Newton. Find the stress in the wire. So here diameter is given. So diameter is equal to 1 millimeter. From this you can find the radius. So radius is nothing but diameter by 2, which is nothing but 1 by 2, that is equal to 0.5 millimeter. So this is the radius R. And a force F is given as 10 newtons. And we are going to find the stress. So what is the stress in the wire? And we know the stress is given by, stress is equal to force by area, but here area is not given, so instead of area you can write pi r square. So force is given as 10, so 10 divided by pi is nothing but 22 by 7, so 7 becomes to numerator, into r. R is nothing but 0.5 millimeter, so I have to convert millimeter into meters, so it is 0.5 into 10 power minus 3 meter. So r square, so it becomes 0.5 into 10 power minus 3 square. because it is r square. So this is equal to 10 into 7 divided by 22 into 0.5 into 0.5 into 10 power minus 6. When it comes to the numerator, it becomes plus 6. So this is about the stress. And 0.5 can be written as 5 by 10. This is equal to 10 into 7 into 10 power 6 divided by 22 into 5 into 5 into, so 5 by 10, 5 by 10 becomes 100. So it is 10 power 6, 7, 8 and 9. So this is equal to 7 by 22 into 25 into 6, 7, 8. It becomes 10 power 9. So by simplifying this we get it is 1.273 into 10 power 7 Newton per meter square. This is about the stress. Okay students, so here we have given diameter and from the radius we find the radius. From the diameter we find the radius and the force is given as 10 Newton. And we are going to find we are going to ask the stress, and stress is nothing but force by area, so which is nothing but force by area is nothing but pi r square, so F by pi r square. So by substituting this value we get the stress value, which is nothing but 1.273 10 power 7 Newton per meter square. So see the next problem. The problem given as a tungsten wire of length 20 cm is stretched by 0.1 cm. Find the strain in the wire. So the length is given, length is equal to 20 centimeter. So the length is given, and stretch is nothing but increase in length. So given as 0.1 centimeter, this is L, and increase in length is nothing but delta L, so which is given as 0.1 centimeter. And we are going to ask the strain. So what is strain in the wire? Okay student, so the tungsten wire of length 20 cm is given, so which is nothing but L, and the stretch is nothing but increased length is given as 0.1 centimeter, and find the strain. And we know the strain is nothing but, the formula for strain is increased length by original length, that is nothing but delta L by L. So delta L given as 0.1, whereas L is given as 20. So here both are given in centimeter, so that's why we are not converting into MKS. So even though we convert into MKS, they get cancelled because strain has no units. So this is equal to 0.1 can be written as 1 by 10, so 1 by 200. This is equal to 1 by 2 into 10 power, so minus 2. So this is 100 and brings to numerator becomes 10 power minus 2, and 1 by 2 is nothing but 0.5 into 10 power minus 2. So this is nothing but 5 into 10 power minus 3, or it can be 0.005. So this is about the strain. So whenever we are asked to find the strain, the formula for strain is nothing but change in length by original length, that is delta L by L. So see the next problem. If an iron wire is stretched by 0.1%, what is the strain in the wire? An iron wire is stretched by 1%. So stretch is nothing but increase in length. So here the percentage is given. So stretched is equal to 1%. So this is nothing but, so change in length by original length. This is nothing but delta L by L is equal to 1 by 100, and we are going to find the strain. So strain is nothing but delta L by L, so this is equal to 1 by 100, this is equal to 0.01. So strain is nothing but delta L by L, so which we will get as 0.01. So see the next problem. The problem is given as a brass wire of diameter 1 millimeter and length 2 meters stretched by applying a force of 20 Newton. If the increased length is 0.51 millimeter, so they are asked to find the stress, strain, and also the Young's modulus of the wire. So see the data. The diameter is given as 1 millimeter. So radius from the diameter, you're going to get the radius, so which is r is nothing but diameter by 2, which is equal to 1 by 2, that is equal to 0.5 millimeter. So here all the remaining is, so the radius is 0.5 millimeter and the length is given as 2 meter, length L is equal to 2 meter, and the force F is given as 20 Newton. That is the increase in length. So which is denoted by delta L is given as 0.51 millimeter. So convert this millimeter into meters. It is 0.151 into 10 power minus 3 meter. And here also it becomes 0.5 into 10 power minus 3 meter. And in the first bit we are going to find the stress. So we know the formula for stress. So stress is given as force by area, and here since area is not given, so instead of A we are writing pi r square. So F is given as 20 Newton, whereas pi is nothing but 22 by 7, whereas r is 0.5 into 10 power minus 3, so it is 0.5 into 10 power minus 3 square. So this is equal to 20 into 7 by 22. So 5 can be written as 5 by 10. So 5 into 10 becomes in the numerator into 5. So into 10 into 10 power minus 6. So this is equal to 20 into 7 divided by 22 into 25. So this is equal to 10 square into 10 power 6. So this is equal to 20 into 7 by 22 into 25 into 10 power 8. So by calculating this we get 2.54 into 10 power 7 Newton per meter square. So this is about the stress. And in the second bit we are going to find the strain, and strain is nothing but delta L by L. So delta L is 0.51 into 10 power minus 3 divided by L is L is 2 meter. So by calculating this we get 0.255 into 10 power minus 3. So this is about strain. Strain has no units. And coming to the Young's modulus, so Young's modulus is nothing but stress by strain. So already we find stress as well as strain. So this is equal to stress is 2.54 into 10 power 7 by strain is 0.255 into 10 power minus 3. This is equal to, on simplification we get, so on simplifying we get 9.984 into 10 power 10 Newton per meter square. So this is about the Young's modulus. So here stress is nothing but force by area, strain is nothing but delta L by L, and Young's modulus is stress by strain. So by using this formula you can find the Young's modulus. So students, in this session we have learned some problems regarding stress, strain, Young's modulus of the wire. So that's all for this session. We will meet again in the next section. Until then, have a great day. Thank you.